Cyber wonders everywhere. Cyber wonders everywhere. Yes. Hello, everybody. As you see from the map, just today, 19,200,000 attack occurred just on this map. Means all around the world, and the map is taken from threatcloud.com. And actually, you may investigate this, and this map shows the importance of cyber security. Today we will go deep into network security, which is quite important topic of nowadays. As you may know, in the last several years, computer networks and computer users have been bombarded with computer viruses and these kind of attacks. One of the most destructive viruses was the NIMDA, just admin spelled backward, NIMDA. It was launched in the beginning of 2001, and it infected 140,000 computers in USA. This kind of stuff always happen in the USA. I don't know why. Okay, let's continue. The virus entered the user's computer or web servers via email and really destroyed the systems. And just imagine how much they spent to clean up the systems. $2.6 billion. Oh my goodness, that's really huge amount of money and finance effort. Okay, anyhow, the following years, several viruses also were launched by the vandals, and as an example, we may show Sobik, SQL, Slammer, Yaha, Lirva, even Netsky, and Bagel. They were struck in the following years, and that's why the systems, the corporatives, the companies, the private systems, even the governments, they came up with this question that what kind of data security techniques we may use. And actually, data security, the network security, came up with plenty of techniques, which we will investigate most of them today with this lecture. As a textbook, we are using Data Communications and Computer Networks Business Users Approach. That book is quite nice. Almost all around the world, the universities that are specialized on the network management or computer engineering or information technologies, they are using this book. Even if you are not professionalized on this field, still as an internet user, as an ordinary user, you may find this book very helpful, at least to be acquaintance with the basic terminology. We will recognize today within this lecture the basic forms of system attacks. We will recognize some concepts on techniques that we use to control access to computer or networks. We will discuss the strength and weakness of passwords, the IDs, and we will see which techniques we use to encrypt and decrypt the data, which can be the subtitles of cryptography. I'm sure most of you have heard about cryptography, because cryptography is quite old topic. Almost 5,000 years ago in ancient Egypt, the kings, the pharaohs, were using cryptography to message with each other. Okay, we will then cite the techniques to use the secure communications. Even we will see how to make wireless communications in local area network more secure. Alright, let's start with standard system attacks. Almost every internet user have an idea of virus. What is computer virus? Actually, simply, we can call the virus the mobile malicious code, or we may call it Trojan horse, or we may call it worms. Actually, they have tiny differences, but the main idea is same. They are malicious codes, and you may consider them as a small program that alters or changes the way computer operates without the knowledge of the computer's users, and often does various types of damage by deleting or corrupting data and program files, and or even changing the operating system components so that computer operations is impaired. But a key point is this happens without the knowledge of the computer's users. That's the key point, because almost it's impossible to interfere the process. Another type of attacks are implemented in a form of worms, and the computer worm is also a program that copies itself from one system to another over the network, and that also happens without the assistance of human being, the user. Actually, the worms usually propagate themselves by transferring from computer to computer via email, and then you see the warning notifications on Gmail that you shouldn't open this email or this spam because the source is unknown or the data that it contains it may be harmful for your device. And typically the virus or a worm is transported as a Trojan horse. Actually, the Trojan horse is hiding itself inside a harmless looking piece of code. Email also can be example for this kind of attack. And all the systems has some weakest links, and the companies, the corporates, they are announcing the dates that they will release the patches. Actually, the patches are programs that repairs or fix the holes, the weakest links, in order to make the system more secure. Then even some hackers, they are waiting companies to announce the date that they will release these let's say the patches. Okay, other standard attacks are denial of service attacks, email bombing, and botnets. The logic behind of them are quite easy, just keeping the service busy. The bombarding computer site with so many messages that site is incapable of answering valid requests. Actually, it's busy with the illegitimate requests, and it doesn't have time to operate properly. Then email bombing, as the same thing goes, because the user sends an excessive amount of unwanted email to someone. The malicious programs that take over operations on a computer comprised the infected computer. We also call them botnets. Okay, let's continue with some other standard attacks, which two of them are phishing and farming. The phishing is actually quite interesting. In some cases, the hackers creates an email that really seems the legitimate request coming from a well-known company, and even email includes some official-looking corporate logos or even emblems, some symbols that the user even doesn't suspect. And in the email, unsuspecting user was asked to provide some private information, such as SSN, the social security number, or credit card number, or some personal data, and the hacker would collect this personal information and use it illegally to purchase items, or even worse, commit identity theft. And actually, this kind of attack, we call it phishing. Another term is farming, and actually in farming the same procedure goes for farming, but a little bit different from phishing, because there is a redirection in the farming, because the system is designed by hacker, actually redirects user to the bogus website that looks like exactly the company's official website. The user doesn't know that he or she visits a bogus website, but they confidently they may enter the information that for registering the system, they may give their personal data, they may give their, let's say, some credit card number maybe, or some personal data can easily be corrupted and easily be stolen. Actually, there's some other standard system attacks are rootkit and keylogger. The rootkit is installed in the operating system, and they are installed so deep within the operating system, even the normal protection software does not even notice the rootkit. Thus, because the rootkit in a place, a user's computer can essentially be taken over by a remote user. Someone else can control your system. That even sounds so dangerous. And mostly the rootkits are meant to be just destructive. And another type of standard system attack is keylogger. Keylogger is a software system that can be used both in positive and the negative aspects. As a positive, you may see the progress of workers, or you may see the progress of users in the system. Of course, it's up to the intention that is used in the companies or in the system, or for even educational purpose. But mostly, it's used to capture someone's user ID and passwords by hackers or the crackers, or other private information. And even some companies, they use keyloggers to monitor their employees' productivity or habits. And really, this kind of use can be either good or bad, just it depends upon the frame of reference. That's it. Actually, up to this point, we have seen some standard system attacks, how they're performed by the thefts and vandals, cyber vandals. And now it's time to see some protection methods and techniques. And we will begin just by examining what we can do for our equipment or our data or system or networks to protect them physically. And actually, the physical protection consists of the basic knowledge that for example, to protect our system from the earthquakes, heat, damage, electrical protection from power surge, or noise protection from placing computers away that, as you know, the electromagnetic waves can interfere to the system and make some noise. Physical protection somehow can be related to network security. Mostly we are interested in to protect our data on the network base, and the cameras maybe can also be an example for providing the record of activities in order to protect the data or the system, the physical system. The physical protections, as it comes from the name, it is more likely the physical protection of the system rather than on the network base. Okay, let's see why we need to access control. Limiting the time of day access, limiting the day of week access. Okay, you may ask a question, why do we need to decide who has access to what? Why? Okay, as an example, let's say if an employee simply performs data entry operations, he or she probably shouldn't be allowed to access to payroll information. Likewise, the employees working on payroll need to the payroll database. They need to have an access to payroll database, but more than likely they do not need an access to information regarding corporate research programs. Let's say, yes, every user has to have some limiting time of the access, or limiting access to what? Actually, the access rights are defined by Chief Information Officer, CIO. Probably you have heard about CIO, Chief Executive Officer, but it's Chief Information Officer. They actually often work together to decide how the company should be broken up to information access groups. As you see from the figure, 12.2. It's a sample dialog box that from a network operating system. Probably it's NetWare, yes. And it's the chief information officer sets the time of day restrictions, up to which time who can have an access to the system. Let's say if the primary activity in one part of your business is accessing personal records, and this activity is performed only during working hours by employees in the personnel or let's say human resources department, then it might be reasonable to disable access to personal records after working hours, for example from 5:30 p.m. Till 7 a.m. the next morning. That's quite logical. And after controlling access that we have mentioned enough, let's see the password and ID systems. Everybody has an idea about the passwords, because when we enter these systems, the first thing is required from us are passwords. Actually, the passwords, you may consider them as a most common form of security, but they are actually the most, let's say, vulnerable technique to protect the data. Why? Because sometimes they can be easy to guess. They can be known or misplaced or fall into wrong hands in the worst scenario. For example, when you write your password on a paper and it's found by someone else, that's obvious that your data is under the risk. And there are some standard rules that can be helpful for all users to protect the data. For example, you can change your password often, then it will not be so easy to guess. Also, the main principle is your passwords shouldn't be guessed easily. That's why you shouldn't share your password or write them down, and you shouldn't select the names or you shouldn't select the patterns that can be guessed easily, like your favorite pet name or your car brand names or some other choices that can easily be guessed. For example, in banking systems, when you get your credit card, it's written on the envelope that do not even share your passwords, even the bank workers. Can you imagine how serious the topic is? Even you shouldn't share your password with the bank workers. But the passwords are the systems, the techniques that we developed, which has the weakest part, the guessing part. That's why in some developed countries they come up with idea of biometric techniques. They are beside the password, they are using some combinations that altogether they are making the network or personal data more secure, like fingerprints, face prints, even retina or iris scans, voice prints, and ear prints. That's quite interesting. Even UK, United Kingdom, they come up with the idea of the large database of ear prints, because the research shows that no two ears are the same. Thus, ear print is useful in helping to identify an individual. That's why beside of fingerprints, they are using ear prints, yes. And actually there's some systems, even some mobile phones, just when the lockup screen, it requires both fingerprints or both, let's say, the face prints, or maybe both retina scans and fingerprints to make the data more secure. Okay, the auditing, let's mention about this a little bit. The auditing a computer system is often a good way to deter crime and can also be useful in apprehending a criminal after a crime has been committed. Computer auditing actually involves having a software program that monitors, that sees and records every transaction within the system. and actually it records into a specific electronic log along with the date, time, and even owner of transaction. That's obvious, as you see from the figure, that it's Windows Event Viewer example. That can be the good example for let's say auditing. Yes, now we came to the best part of cybersecurity, the encryption and decryption techniques. Cryptography is a study of creating and using encryption and decryption techniques. We have plain text, we have an algorithm, key, and ciphertext. Then again, we need to decode the decrypt, actually the ciphertext, in order to get the previous plain text. The key is a unique piece of information that is used to create ciphertext and decrypt the ciphertext back into plain text. And for getting ciphers, we have several techniques: monoalphabetic and polyalphabetic substitution-based ciphers. In monoalphabetic substitution-based ciphers, we replace a character or characters with a different character or characters based upon some key. Let's say replacing these letters A, B, C, D, A, F, they just English alphabet letters, and we replace them with this key P, O, I, U, Y, etc. It goes on. And let's see if we want to send a message. How about lunch at noon? It encodes to EGVPO. Okay, how? When we go to age, we want to write the word how. When we go to age, just okay, these two lines are a little bit shifted, but when we put them in the starting point, the same starting point, we see that just the matching letter for H is E, for O it's G, and for W it's V. And we can use this monoalphabetic substitution-based cipher, and we can actually encrypt, encode any letter or any sentence we want. In polyalphabetic substitution-based cipher method, actually it is similar to monoalphabetic cipher, but the point is it is the matrix of strings 26 by 26 matrix, and we are choosing the key, and it's placed repeatedly over the plain text. Let's say this class on data communication is the best. That's the plain text, and the key is computer science, and computer. Actually, the number of letters that used in plain text and the repetition time of computer science, the keyword, should match each other. And to encode a message, we go to the matrix. Let's say this is actually this class on data communication. Let's say this class is on data communication is the best. We want to encode this by using this polyalphabetic substitution-based cipher. We go to see how can we send the T. Actually, we go to column C because it started computer science C, and we go to find T column because we found the row C, and when we go to T column, we see that it is V. Yes, that's V, and by using this matrix, we can retrieve the cipher character for each letter in the plain text, and we can continue with the other characters in the plain text also. Another method is transposition-based cipher. Actually, I find this method more secure because the plain text is not preserved, and as a simple example, we are choosing key, which when we interchange the letters, we don't get any other words. Like when you use the word computer, and when you try to get another word by using the same letters that you used in computer, which is actually not possible to get another word that using the same letters that used in computer. And we are giving the number in alphabetic order. For example, C comes first in alphabet, and among these letters, the second one comes T. That's why we number this one with 2. Computer, C-O-M-P-U-T-E-R. T comes after C, and after T the letter comes M. The fourth one is O, and it goes on like this. Okay, we want to encode the sentence, "This is the best class I have ever taken." This is the number of words in letters in computer is 8. This is TH, it makes 8. THISISTH, it makes 8. EBA, that one also makes 8, because T comes first, and then we are numbering this in this, actually the chain, we are numbering with the words, the letters that repeated. And just the first one, we read them down the columns, starting with the column number 1 followed by column number 2. Okay, the first one is TESV, the second one is actually is TLEE. You may get a little bit confused because the words are back to back, but actually they are in the same length, because all of them consist of 8 letters, 8 characters. After reading the column number 1 and followed by column number 2, 3, 4, 5 up to 6, this is the message that we get. TSVTLEE, that's the message we get. Okay, when we mention the cryptography, the two main things that we have to mention is public key and private key. Actually, the public key is used for encryption of the message, and the private key is used for decryption of the message, and that's not possible to deduce the private key from the public key or vice versa. And if you want someone to send you secure data, give them your public key, you keep the private key. And when your data is encrypted, it's almost impossible to get your original data or to get your private key, because you keep it at yourself and you are encrypting your data by using public key. Some advanced encryption standards that I want to mention are standard of 64-bit block of data, and this data is subjected to 16 levels of encryption. Actually, the combinations, the number of combinations are quite high, and the data encryption standards, DES, is commonly employed encryption methods used by businesses to send and receive secure transactions. Actually, the encryption techniques are based upon substitution and transposition-based ciphers. Each of the 16 levels of encryption can perform a different operation based on the contents of 56-bit key. Actually, it provides the 72 quadrillion combinations. A system using this standard has been cracked, unfortunately. Even with this amount of combinations has been cracked just in 3 days. And there was a debate in USA in July 1998. The government side of the debate suffered a setback when a group called Electronic Frontier Foundation claimed that it had cracked 56-bit key in 56 hours using a single customized personal computer called DES Cracker. They even designed a special computer for cracking these combinations. And actually, another encryption and decryption methods came up with after this, the cracking, because the combinations were not enough to make a data communication more secure. Then they came up with the idea of advanced encryption standard, and this time the key size were more larger. It was 128, 192, and 256 bits even. Actually, there was a calculation on that estimated time to crack these combinations, and it will take 149 trillion years. Actually, some advantages of advanced encryption standard is it's very fast, and it can be used with very good use of resources. Okay, now let's examine some of the more recent advanced techniques that we are using in cryptography, and one of those is digital signatures. Okay, suppose that you are sending money from your country to abroad to your friend, or from another country that you are studying, let's say from the Cyprus. I want to send money to my family, to Russia, let's say, and I go to Western Union and I actually sign a paper. And my sign is when I enter my details, the amount of money that I want to send, and then I actually enter handwritten signature. But when we take money from the credit card or bank card, we are just entering the PIN. Actually, if it's not stolen, or if it's not written on the paper, and if it's not got in the dirty hands, the PIN system is quite secure. But let's say there is an electronic document and we have to sign this document so that later on we will be able to prove that it's ours. Okay, that's where we need digital signature. Digital signature is nothing but a security procedure that uses public key cryptography. And okay, let's examine in more detail that how it works. Actually, the main term that we will use in digital signature for understanding the digital signature is hash. Okay, first, the digital signing an electronic document involves sending the document through a complex mathematical computation. Actually, by this process we are generating large prime number that we call it hash. And the hash and the original document, actually they tied all together. And if some of them altered, like the document or hash altered, actually it's obvious that they will not match and it will not be possible to decode the document. And then it becomes more easy to prove that the document belongs to the user. Okay, but that's not quite easy as it sounds, because before proving that, let's say that later on someone argues that this document belongs to me, then the system in the system the new hash is created for the document, and then the original hash, which has been encrypted with the owner's private key. Actually, that is the key point, the owner's private key, because the hash has been encrypted with the owner's private key, and then it's decrypted by using the owner's public key, and then we actually compare two hashes, and we obviously it's seen that they are agree, and then we say that okay, this digital signature is valid. Okay, you may come up with a question that we didn't see the user signed this document. There can be an argument that it's not possible to prove that she or he did not see the user signing the original document, and that's why we don't know that if the document is legitimate or not. But actually this argument can be easily resolved by the fact that only that user who argues that okay, I created this hash, I used this digital signature, actually only that user have this private key, and by only using this private key we can create this particular encoded document. That's really the key point. The nice part of digital signature is the using of this private key stuff. Okay, let's move on with pretty good privacy, PGP. PGP was developed by American entrepreneur called Philip Zimmerman. And why he came up with this idea, we may ask, because he thought that what kind of encryption system can be developed for the usage of any average person. And he came up with this idea, pretty good privacy. And this is high quality encryption software that has become quite popular in the United States of America. Actually, it was used on the USA because the some federal laws do not allow to send encrypted data to the abroad of United States, and actually the Zimmerman himself had some legal trouble issues because I think he allowed his software to leave the United States, which violated federal export laws. Of course, we don't know how. And this law banned some external transportation of encryption software. In the United States, as a user, it's almost free to apply PGP to your document, but for some, let's say, the professional intentions, requires some, let's say, payments. It doesn't become, but for using the personal issues, actually, non-commercial, let's say, installations, you don't need to purchase anything, it's free, but it's obviously can be used only in USA. Okay, another authentication protocol is Kerberos, and Kerberos is let's say similar to pretty good privacy. It is used for authenticate the users. Let's say the client workstation requests the service from a web server, and the web server obviously wants to be sure that client is who he or she claims to be, that there is no fake let's say the request. And that's why we are using Kerberos. Kerberos can provide this authentication. How? By presenting the ticket that was originally used by the Kerberos authentication server. And actually, it's not so complicated as it sounds like, because the client presents a ticket that was originally used by the Kerberos authentication server, which in this ticket there's a password that was selected by the client at an earlier time. And then server accepts the ticket along with the private or public key, and it checks the transaction request, and it examines the let's say the request in this way. Okay, let us continue with public key infrastructure. The PKI, simply as an abbreviation, we may call it. Public key infrastructure is a combination of encryption techniques, software, services that involves all the necessary pieces to support digital certificates, certificate authorities, public key generation, storage, and management. As you see, the public key infrastructure is a quite new technology, quite new techniques that are used all together to make data communication more secure. This system is really quite expensive, and the heart of this infrastructure is digital certificate. And digital certificate is nothing but an electronic document which is similar to passport, and actually it's used when we are performing the transactions, because it is establishing our credentials when we are performing these transactions. And the digital certificate, as we mentioned, that is similar to passport, contain our name, serial number, expiration dates, a copy of our public key, and a digital signature of certificate issuing authority. Actually, these certificates are issued by certificate authority. Mostly they are the trusted third party. As an example, we may give the VeriSign. VeriSign is an example of trusted third party. And let's consider this scenario. Let's say that the user wants to order something over the internet. Firstly, the website wants to make sure that we are legit or user is legit. So the web server requests from the browser to sign the order with the private key, which is obtained from our certificate. And then the web server requests our certificate from the third party, let's say VeriSign, and it validates that certificate by verifying third party signature, then uses that certificate to validate the signature on our order. That's how the PKI works. Actually, there are some fields that, let's say, applications that could benefit from PKI, and these are web transactions, virtual private networks, electronic mail, and even banking transactions. But the disadvantages of PKI, this system is expensive. That's quite expensive because still it has some problems, and the system is quite new. For just medium-sized businesses, the price changes from thousands of dollars to hundreds of thousands of dollars just for medium-sized businesses. And moreover, some PKI systems are not appropriate to interact well with other PKI systems. That's also another problem. But hopefully the price, like that most of the technologies, is constantly dropping. That's really the positive side of public key infrastructure. All right, the last part of encryption techniques, we will discuss steganography. Let's spell it correctly, steganography. Yes, steganography. The word is quite difficult actually to pronounce. That's a little bit different from the encryption methods because it is the art and science of hiding information inside other seemingly ordinary messages or documents. And when we encrypt data, it's obvious, you may know it, but it's almost impossible to see the message that is hidden within a document. That's really requires quite expertise, and let's give some mathematical information that what happens in the backstage. Let's say that mostly steganography is used in digital images. It takes most of the attention nowadays on hiding some secret messages within digital images. If the image is black and white or it's colored, it's common to have 8-bit pixels that represent 256 different colors. And if we consider that typical image size is, in the perspective of dots, 640 multiplied 408 matrix, and we may call it as a pixels. And each pixel is 1 byte, or let's say 8-bit. Each dot, let's say 8-bit pixels. Then total bits are more than 2.4 million. And currently, there are several ways to hide the secret messages within these 2.4 million plus bits. So far, we have examined standard system attacks, physical protection, controlling access, and securing data. Now, we will examine the details of securing communications. And actually, if you want to listen to the particular stations, let's say the FM on the radio, you have to tune your radio or let's say receiver to the same frequency on which that station's transmitter is broadcasting. Let's say you want to listen to Barek International in the North Cyprus, one of the famous radio stations, and the frequency is 106 megahertz, and you have to tune your radio to that according frequency. And actually any user within listening range of the transmitter can tune to the same frequency and listen. Okay, let's say that it works well for commercial radio, but it has always been a serious problem for the military. Because when one side transmits military information, it generally does not want the enemy to be able to hear it. And in such cases, somehow the transmission must be made secure somehow. And actually, even if it's captured by the enemy, it shouldn't be understood. That's also another key point. And one of the oldest methods for securing the data in order to transmit without having any trouble, the spread spectrum technology is used, and actually it transmits the data, let's say, not in a fixed bandwidth. It transmits, it spreads it over a wider bandwidth, and by spreading the data, level of security is incorporated, and it's more difficult to wiretapping or eavesdropping the signal. Actually, one of the most common commercial applications of spread spectrum technology, SST, is wireless communication. And there are two basic spread spectrum technologies. One is frequency hopping spread spectrum, and other one is direct sequence spread spectrum. And we will examine each of them in a very detailed way. Okay, let's examine the spread spectrum technology. And as you see from the figure, the channel encoder wants to encode the input data. As you see, the data is digital and it's encoded to analog signal, and it transmits the scrambled signal to receiver, and receiver decodes that scrambled signal to analog signals, and also after decoding it decodes it to output data that originally was digital data. Okay, but a question arises in this point that the analog signal that sent from the encoder, from the transmitter, let's say, has different frequencies. Okay, it is calculated, it is programmed to do so in order to not get the captured by the enemies, or let's say, or the dirty hands, in order to not have the information on the dirty hands. But how is the basic operations behind especially the receiver part? Is it possible for a receiver to accept the signals which the frequency almost changes? And actually, it's not possible to listen to this data, to catch this data, because this frequency changes. The frequency changes, and question arises that how does the intended receiver follow this random bouncing around of frequencies? From the perspective of hardware and software, it's almost impossible. But then it turns out that the signal does not actually bounce around the random frequencies. It only seems to do so. That's quite smart technique actually, because the transmitter actually follows pseudo-random sequence of frequencies. What does that mean? In the receiver part, it has a position of hardware and software knowledge to follow this pseudo-random sequence of frequencies. That's quite smart, isn't it? And that's why it's easily possible for receiver to get this signal. And for corrupting this data, that's really difficult because the knowledge in the receiver, what is the range of pseudo-random sequence of frequencies, it's almost impossible to know this. Only receiver part has this knowledge as a hardware and software. That's why easily it can cache this data. Okay, another technology that used as a subpart of spread spectrum technology is direct sequence spread spectrum. This technology replaces each binary 0 and binary 1 within the unique pattern or sequence of ones and zeros. Okay, let's say these two data want to be sent, and the first one for each binary system, the transmitter use 1, and the other binary number it uses 0. Another transmitter may use ones and zeros for different patterns. Actually, this figure shows, as an example, it shows how direct sequence spread spectrum happens. As you see, some Boolean algebra operations happens within the process. Firstly, we see the input data A, and then the system chooses, similar to the frequency hopping, it chooses a pseudo-random bit sequence B, and then it transmits XOR signals A XOR B, and you may examine these graphs by just using simple Boolean algebra, let's say tables, and after receiving data, actually it XORs with pseudo-random bit sequence in order to get an original signals. Okay, let's see the details of programs that guard against the viruses and details of them, and then we will see firewalls and some basic types of firewalls. Now let's move on with firewalls. There is a huge misconception that firewall is antivirus. Actually, it's not. It's the system or combination of system that supports an access control policy between two networks. And the firewall actually can limit users on the internet from accessing the certain portions of a corporate network, and can limit internal users from accessing various portions of the internet. And this figure actually basically explains how the firewall works, and the firewall stops certain internal and external transactions, like the invalid web page request just is denied by firewall. Firewall systems has three basic types: packet filter firewall, proxy server, and application layer. Okay, let's examine the first one, the packet filter firewall. As it seems, it's actually the essential router that has been programmed to filter out certain IP addresses or TCP port numbers, and this type of routers are relatively simple design, but they act very quickly. But unfortunately, they are a little too simple to provide a high level of security, and for let's say the external user band, it's easy to cause the internal network problems. The second one is proxy server. The proxy server is a computer running proxy server software whose function is much like that of a librarian who controls access to books in a library's rare books section. To keep costly books from getting damaged by vandalism or careless handling, many librarians do not allow even the patrons to enter this rare books room. Instead, the user, the patron, actually request information about that book, and actually it's kind of information request, and it's handled by librarian, and then librarian enters the rare books room and actually retrieves the requested volume. But the librarian then photocopies the requested information from the book and gives the photocopies to the patron. Key point is patron never comes in contact with the actual rare book. Similarly, same thing goes for proxy server. The transaction making a request of company's proxy server, firewall never comes into contact with the company's network. Any external transactions that request something from the corporate network must first approach the proxy server, and proxy server actually creates an application called the proxy, and that goes into corporate network to retrieve the requested information. This really provides very good way to create an audit log. In the previous sections, actually, we mentioned about audit log, and proxy server is more secure than the previous type of firewalls, the packet filtering firewall. It's more secure. And the third one is application layer. And in application layer firewall, it's actually inspecting all packets coming into or leaving a connection using the application layer of TCP/IP protocol suite. If you don't know the details of TCP/IP protocol suite, actually the first chapter of this book, the detailed information may be found. And the application layer firewall goes beyond IP addresses and TCP port numbers, and actually it's inspecting each packet to see if it belongs to an application or not. The most important question we may come up with is how efficient is firewall systems. Unfortunately, they don't protect the network from all possible forms of attack, because imagine if the virus can hide within a document, it will probably not be detected by a firewall if its host document is allowed into a system. And some firewall systems, however, do boast that they can detect the viruses within documents, but these systems are rare and may not detect all current viruses. And also the firewall will not protect the computer or network properly if it's possible for an intruder to, let's say, avoid the firewall and enter the system through an alternate route. How it happens: for example, if a network system has one or more dial-up modems that are not part of the firewall system, the perpetrator can bypass the firewall and gain illegal access. Unfortunately, that's also another verse. All right, now we will mention about the wireless security, how we may arrange wireless local area network more secure, and there are some protocols to actually use for security issues. And the first security protocol for wireless local area networks was WEP, and what the that's abbreviated form. The wired equivalency protocol was first security protocol, but it had actually two main drawbacks, and one of them was the size of keys. It was 40-bit, and another drawback was it was static. And the static and the short bit keys actually are more vulnerable than the dynamic and long size keys. That's why this Wi-Fi protected access WPA came out after VEP, and major improvement was the key size were same. Actually, it was 40 bits, but the static keys became dynamic, and then both of these protocols actually created a way for the improvement of IEEE 802.11i, or simply WPA2. And actually the encryption algorithms, the size of keys were changed, and the advanced encryption standards based on Ryan-Dial algorithm with 128, 192, and even 256-bit keys. And this protocol is based upon WPA and the Robust Security Network (RSN) software that performs a robust negotiation of the encryption and let's say authentication algorithms used between access points and wireless agents. Okay, now let's give some basic needs of companies for security policy design issues. And actually, when the company is designing a firewall system and its corresponding security policy, a number of questions should be answered. The first question involves the company's expected level of security. Is the company trying to allow access only to a service deemed essential to its business or not? And the another is, how much money is the company willing to invest in security? Or is the company serious about restricting access through an internet link? What about restricting access through all other entry ways? And network security actually requires many routers to be programmed to restrict access to certain kinds of traffic. And the router can be programmed to accept and reject requests with specific IP addresses or range of IP addresses. Really, too many questions should be answered and too many details should be considered in order to make the security of company well designed. At the end of this chapter, in the light of this data and knowledge of network security, let's put this knowledge in action. The book gives example of Hannah, and if you have any acquaintance with book from the chapter 7, now Hannah tries to make her wireless local area networks more secure. Which kind of software she has to install, and which system she has to use for this local area network. Actually, the systems that we mentioned before have their weakest links. That's why, fortunately, nowadays the WPA2, the system that we mentioned the last part of the previous section, now available for wireless local area networks. And this system have several advantages. First is it has stronger encryption methods, and this system use faster algorithms. That's why it's really hard to beat, because it came up with the key sizes of 128 and even up to 256 bits. And actually, this clearly looks to be the best encryption software for a wireless local area network. Hopefully, the Hannah will not encounter any compatibility problems even, and actually she can easily and confidentially consider installing WPA2 system, and because the passwords can be dynamically assigned, and the corporate network will be secure from the wall drivers outside of the building. Okay, this is the summary parts of the data and the knowledge that we have been using in this chapter. Thank you for listening and watching to the lecture on computer network. If you are interested in more details in cybersecurity, please just get an access to this book. The book is quite nice and well written, and as an ordinary user even, you may find it so helpful. Have a nice day. Good luck.